Today, I'm Sait Turksever. I'm project manager at Meta. I'm part of Meta's open mapping community team. Today, I'm joined with Yunzhi, and we are presenting today.
Yeah, hi, I'm Yunzhi. I'm quality analyst at Meta for MetaMaps.
And yeah, this is our quick agenda today. So a quick introduction, problem definition, and then I'll be covering also methodology, and I will be handing over to Yunzhi for QA implementation, and then also for concluding the presentation. So in the introduction, we have Mapillary overview, and then how to Mapillary, and then Mapillary's map data extraction capabilities. And simply, Mapillary is a street-level imagery platform that scales and automates mapping. And we have a contributor network and partners, and they're uploading imagery to Mapillary, and then we run object detection and 3D reconstruction from those images, and then we are extracting map data. And it's quite simple to capture and upload imagery to Mapillary. You can use any camera, smartphone, action cameras, dash cam, and also mobile mapping equipment. And then you can use desktop uploader and then Mapillary tools or smartphone to upload your imagery to Mapillary. The only requirement that image needs to be geotagged. And once the imagery will be uploaded to Mapillary, so as I mentioned that we run semantic segmentation to understand each of the object of each image, and then also generating 3D model from the structure for motion. And then after that, we are positioning each object on the 3D model. So globally, we extract 42 street assets, and then more than 1,500 traffic signs can be extracted from Mapillary. Cool. So basically, it sounds so simple. You capture, you upload imagery, and Mapillary does the magic, and then you extract imagery. But the question is how is the quality of those extracted map data? Today, we are going to talk about what is the quality of Mapillary extracted data in terms of recall, precision, and then positional accuracy, as well as we are going to compare existing OSM traffic sign data against Mapillary traffic sign extraction. And in this talk, we are going to only focus on the stop sign. This is where we did an experiment on the stop sign in San Francisco, Bellevue, and Redmond area. And all the following analysis and the results will be related to stop sign. Cool. I will simply cover our methodology. So we have 4 main pillars: data collection, data processing, data analysis, and data ingestion in our methodology. And we collected ground truth data, literally, with the surveying methods to understand what is the quality of machine-generated data. And we collect street-level imagery using GoPro Max camera. And we upload all the imagery to Mapillary, and then Mapillary extract traffic sign for us. And then after we do pairing, we link all the ground truth data with corresponding stop sign. And then Yunzhi will go deeper into our QA implementation. In the end, we calculate our recall position for our machine extracted data, as well as positional accuracy, and also we run analysis on the OSM coverage when it comes to stop signs. In the end, we compilate all the data which is existing on OSM with the Mapillary generated data, and then we contribute it to OSM. All right, I will hand over to Yunzhi.
Okay, thank you, Sai. So to implement the methodology, Sai just mentioned that we design these workflows. So we start from fieldwork to collect ground truth data and street level imagery, and then we process the street level imagery using series Mapillary developed, and then generate the map data such as traffic signs. And then we build internal QA tooling to pair the ground truth data and the Mapillary generated data together, so we can verify the accuracy of the Mapillary generated data. We upload the QA results which is the accuracy results about the Mapillary generated data. Currently, we conflated the ground truth data with OSM data, and we push to OSM. But what we plan to do is we conflate both the ground truth data and the Mapillary generated data, referring to the QA result, which is the accuracy verification result, and then conflate it with OSM and push the data to OSM. So this slide shows the verification results that we have. On the right side, you can see how the Mapillary generated data look like in red and how the ground truth data look like in blue. So our results here shows that we have a relatively high recall for the stop sign, the Mapillary generated stop signs in all the area of interest. However, we have relatively low precisions for the Mapillary generated data. We did further investigations on why the precision is relatively low, and we find out that's likely to be caused by the temporary traffic signs that we see on the road because of construction, or possibly caused by some missing ground truth data. But the positional accuracy is all within, they're all within 3 meters, so it's relatively good in our opinion. Since we are considering to push to add the data to OSM, we also check the OSM stop sign coverage. And we find out currently on OSM, among all the area of interest, like the Bellevue downtown, Redmond, and San Francisco downtowns, the OSM coverage against ground truth data, plus the OSM coverage against the Mapillary data, it's pretty low, which means that both shows that OSM is missing a significant amount of stop signs. So we have a project recently that added the stop sign to over 200 intersections in San Francisco, Bellevue, and Redmond downtown. So with this experiment, it shows that the Mapillary can actually generate that object, which is the Mapillary data with like over 95% on average of the records, with 2.5 meters of average horizontal precision accuracy for stop signs. We actually implemented these experiments on Yunzhi and pedestrian crossing as well, and that gives us 2.16 meters of average horizontal precision accuracies, which means that more data that it proves that we could do even better jobs. And our stop sign data, the experiment also shows stop sign data on OSM is incomplete. The previous chart that already tell that there are in between 70 to 90% data missing of stop signs on OSM. And the entire experiments also prove that street level imagery and Mapillary generated map data actually play an important role to help completing the missing traffic signs infrastructure on OSM. In the future, we're planning to improve the horizontal precisional accuracy of Mapillary generated map data using control points. We also plan to expand our conflation work to wider Mapillary generated map data, not just stop sign or Yunzhi and pedestrian, but any traffic signs or other Mapillary generated data as well. And we plan to develop better conflation strategies between the Mapillary generated data and OSM data. But currently, it's not universal. It's quite local in terms of a conflation strategy for the stop signs. So we plan to expand it to more universal approach and apply to make them more applying to different variety of data. We also plan to build the easier workflows for ingesting the Mapillary generated data to OpenStreetMap through Rapid. Yeah, that's all. Thank you.
Thank you very much.